Now let's talk about programming paradigms. Now, what do you mean by programming paradigms? This is the philosophy of uh, writing a program, right? So if I take programming paradigms, okay, I can divide this into two broad categories, and these two broad categories are going to be functional programming and imperative programming. So, what is a functional programming? Okay, we have seen some examples of pure functions and higher order functions, right? So if your focus, okay, is a function, right? If your focus is a function, and function is the first class, objects, or rather, first class citizen in case of this uh, functional paradigm, right? So what I mean by first class object, okay, function itself is a object, right? So if I was to define a function, for example, right? So if I say def and say sum num, and I give it two numbers, num1 comma num2, and I was to return num1 plus num2, right? Then this itself in memory is treated as an object. So how do I know that? Because the identifier sumnum points to an object which is stored at a certain location. So how do I know that? If I do a print on this function, which is sumnum, right, and look at it, let's see what it looks like, right? So if I debug this, okay, it says function sumnum at this location, right? So there is a location to which this identifier is pointing. Now let's look at the type of this. So if I write here print function here and say type of sumnum, right? Type of sumnum, and see what this is. So you'll be surprised to know that this is actually an object. Right. So basically this is class. So function itself is a class here. It's a type here. Unlike some other languages, it is not, right? So it basically is an object, right? So that's what this is. Okay. So having proven that, let's look at uh, what is the other paradigm. The other paradigm is called the imperative programming, right? So what do you mean by imperative? Okay, I will just tell you. Imperative. Okay. Imperative means that uh, uh, a program, right, has got two components to it. Okay. A program has two components to it, and these two components are action and data, right? So these the two components to this imperative programming is data and function, or a method, you can say. A function or a method, right? Or it's a action basically. So I would say data and action on that data, right? So what it means? Okay, it means that uh, action is not the prime focus here. The prime focus is the state, right? So these two basically define what is called the state of the program. Okay. Okay, so when you fix the state, when you fix the variables or the data or the properties of an object, what you are doing is you are fixing a certain state for that object. So basically, an object is a bunch of action and action on a data, and data basically is the one which decides the state of that object, right? So basically, these two are going to decide the state of the object. Okay, and in this form of programming, the idea is to go from initial stage or initial state to a final state. So you start with the initial state and you go to a final state, right? So this is what the imperative uh, programming paradigm is about, right? You go from initial state to a final state, and the states are basically decided by the data variables. Okay, now let me just clear one more terminology. The terminology is properties, okay, and attributes, right? So properties and attributes are used interchangeably, but property basically means uh, a read-only property. Usually it's a read-only variable which is termed as a property, and then there is an attribute which basically participates in the state change, right? So that would be called uh, an attribute. Okay, so let's see. So that would be an attribute. So whenever we deal with states going from initial state to final state, the programming is all about we know the final state and we have to find out the steps to go from an initial stage to final state, and that's what all programming is about. Now this is of two types again, imperative programming. One is called the procedural programming. Okay, so the one is called the procedural programming. Okay, and the key is the underlying element here is a state, right? Even in procedural programming, we are progressing from initial state to a final state, right? So that's what a procedural programming is about, right? It is not functional programming, because in functional programming, the main element is a function, right? While in procedure programming, the main element of importance is the data, right? So that is called procedural programming. And other form of programming is called the object oriented programming. Okay, and object has is in a particular state. Okay, and that's because of the values, right, which are assumed by these attributes, right? So that's why it is also imperative programming, because the object is moving from an initial state to a final state, and with the help of these actions. So there is a concept of assigning. So whenever you assign something in procedural programming or in object oriented programming, when you assign something, then that means that you are changing the state of the object, and you are going through a number of intermediate states from initial to final. So the key element here is the data assignment, or whenever you change a variable or whenever you introduce a new variable, right? So that's the concept of imperative programming. While in functional programming, right, the all the programming paradigm revolves around a function which is action, right? And you would see the assignments usually come at the very end. So basically a function may call another function, which may call another function, which may call another function. When you go to the rock bottom, you are going to see the data, right? So basically in functional programming, uh, the programming is basically functions stacked over functions. So you can say that. Okay, so functions stacked over functions. So then you can say, is it a recursive programming? Yeah, recursion is one form of functional programming, right? Functions stacked over other functions, over functions. Functions stacked over functions. Okay, so that's the nature of the programming. So let's try to explore, okay, what these different programmings are going to be. Now, I think I have made clear what is a function and what is a method. A method belongs to an object or a class, right? It belongs to a type. while function are independent, right? So that's the difference between method and function. Now let us see some example. Okay, let's say the idea is to sum all numbers which are which are either divisible by 3 or divisible by 5. Okay, so now this divisible by 3 or divisible by 5 is like a filtering, right? So earlier we have seen use of filter when we were doing functional programming, right? So we can use that filter also, but let me start with what are the different ways I can write this this program, right? So one is I can generate a list, right? Okay, I can generate a list, so I can say my list is equal to, right? uh, and I can generate a list from a generator like range, right? Okay, so I can say my list is equal to value, okay, for value in range, okay, and that range can be 10, let's say 0 to 9, that's 10, if value mod 2, or sorry, mod 3 is equal to 0, or value mod 5 equal to value mod 5 equal to 0. So now if you see this, I have generated a list, so I can print this. So this is like a filtering function, right? So let me print this. Okay, in the first instance itself, we see that we have worked with the data. Now this will not be called a functional programming, this is an imperative programming, right? Okay, so you now see there is a list which goes from 0, 3, 5, 6, 9. These are all divisible by either 3 or 5, right? So if I make use of this list, okay, to start with, and then I write something like define, okay, and I can say some list, okay, and it receives a list. For example, I don't make a use of this list. Yeah, so I'm just not going to make a use of this list. I'm going to generate this. Okay, so here let's say it receives a list, and or rather it receives a number. Okay, so I'm going to write from very basics. It receives a number, then says for item in range. So this is making use of a generator. Item in range num, okay, do the following. If okay, okay, so let's put here an empty list. Or rather, let's put here a sum, right? Or sm. So now as soon as I put sm equal to 0, I have fixed the state, initial state. Then I'm saying if item is divisible by 3 or divisible by 5, right? If item is divisible by 3 or divisible by 5, say sum plus equal to item, and then say, then we are out of this, we are going to sum off the thing, so it will be called sm, okay, and then I would just say return sum. Okay, so now if you notice this, what did I do? I receive a number. I establish the initial state of sum equal to 0, and then I pass the generator, okay, one by one, and I got the sum, right? So let's print the result. Total of numbers is this value sum. Okay, so now the sum is not available, so I have to call that function sum list, and here I can say 10. So this is one way of writing a code. So the total of 0, sorry, so if it goes like 3, 6, 5, 9, right? So the sum is going to be 23. Okay, so this is one way of writing it. Now let's say if I want to show the list also, right? So I can do one thing. I can make a list first, as I did in the first case, okay, and say list. So this list is a range, right? And you notice in the for loop, what did we do? We are stepping through the states to reach the final state of sum, right? So this is a classic example of imperative programming. So here I'm going to put in a generator, which is range 10, and I am going to define sum list 2 receiving list, and again running the same command, okay, for item in list, right? So basically list. So now we are using more memory. So because here we were using a generator here, range. So our memory was basically we were generating one item at each time. So there were like two variables which were working. One was SM, other was the item, and then whatever was there was a generator. There was no storage of generator in a list, right? So unlike that, we are storing that in a list here. Now is there any performance advantage? Well, this one may be faster because you have all the numbers available in the list, right? So let's see. For item in list, I can say sum, or still I have to do the states here, sum equal to 0, and then you can say sum plus equal to item. Okay, so now you understand the difference between the two. In one case you have only one variable, okay, which one variable which stores the sum and one variable which is generating the item. So basically there are two variables here. Now in this case there would be sum which is already working, plus then you are having a list which has got members, right? So it is taking more space here, right? So in this case it is having 0, 1, 2, 3. So if I display the list, you will see that. So let's do this and let's print it. Print, okay, and here I put a formatted string and say total of numbers in list, uh, list, and the list name here can be my list, okay, is such that number is divisible by 3 or 5 is, and here I can call the function here which is sum list 2, and here I can give the list itself, my list, and that. Now here the list is passed by reference, so no copy of list is generated. Okay, so here if I was to put this would be even worse in terms of memory, because I'm passing a copy now. So I'm not passing a copy, I'm passing it by reference, right? So return line 14. Oh, so we did it. Okay, so this is at a wrong location. Indentation is wrong. That's fine. Okay. Hmm. Most recent call, unsupported operand types for plus equal to int and range. Int and range. Okay, let me just check this. Range 1 to 10. So why? Oh, a mistake here. So this not how you generate a list, right? So that's fine. Hang on. Okay. Okay, so the total of numbers in list 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, such that number is divisible by 3 or 5 is 45. Okay, another way of saying this, so basically here I have done again a recursion, a looping, right? Now if you don't want to do a looping and you want to use some form of a functional approach, you could have written this way also. So let me write it yet another way. I would say sum list 3, and I'm going to pass a list here, and here I am going to say uh, basically I'm going to generate a new list, and in this case I can say okay, and this can be based on a condition. If item is divisible by where is it, divisible by 3, or item is divisible by 5, right? Sorry, item mod 5 equal to 0, then you are going to do this action. Okay, so now here you can say return sum of list 2. Now this is a functional approach where you are using some form of a accumulator. So that's what we saw in reduce, right? So this is of that form. So what am I doing? I'm receiving a list. I don't need this one. Okay, I'm receiving a list. I'm parsing the list to find out the members which are divisible, and then I'm returning the the sum of that list, right? So now in this case, if you do this way, again this list 2 is not available. So right, so what you can do here is once you get this list out of the for statement, you can print here, print okay, you can print here list, right? Or you can directly print here a list. Okay, and let's run this again. Or rather, I have to call this function. Without calling it will not work. So I can take this one and I can put here total of numbers is Okay, sum3 my list. My list, if you know, is 0 1 2 3 4 5 6 7 8 9. So it is filtering that list to make another list, and then it is going to sum it. Is it efficient? Well, it is taking more memory because now it's dealing with two lists, right? So what happened here? Okay, so after if there has to be a colon. Okay. Okay, so now you see the list which is filtered out is 0 3 5 6 9, and its total is 23. So in this case it is 45. So let's see what has gone wrong here. uh, okay, it is summing all of them. So that's not we are supposed to do. We are supposed to do if, again we are supposed to do this, Control C, Control V, and then we are supposed to do this. Okay, so then the answer would be 23. Okay, so in all the three ways I'm getting that 23, but none of them is efficient. Now I can write it yet another way, which is a functional way of doing it. So let's define a function which is called update, and this function update is going to receive some parameters, right? So okay, so it's going to receive a number, and it is going to receive a function, right? So let's say that function is called func. Okay, so this is the higher order function which we are defining now, and then the variable which is iterated through is v, right? And then I can say if v is equal to n, right, then you are going to return a null list. This is an empty list, right? Then if you call this function, if okay, so this is a filtering function, so you can say if func, okay, so if the return value is true, right, if func, then I'm going to return update. So I'm going to return okay, I'm going to return a list which is v, okay, and this plus is equivalent to append, right? So this is appended with update, calling this function recursively, n comma func comma v plus 1, right? So this is a recursive call, okay, and then I can say else return a recursive call. So this is just going to update it. This is not going to append the list, right? So n comma func, sorry, comma v plus 1. Okay, so now this is a higher order function which I have written, right? And I need to call this. And another thing is that it has to return something, right? So I can say, so it is going to return, right? So it is going to return a list. So that's what it is going to do. So I can say print. Then I can say what I want to print. I want to print formatted string, okay, sum of numbers in list, okay, or rather I would save this, okay, I would say list is equal to update. So I'm making call to a higher order function. Here I'm going to pass in the final value, which is 10, and then the function definition, which I can use as a lambda. Okay, and I would say x such that it is a filter, right? So x such that x mod 3 equal to 0, or x mod 5 equal to 0. Okay, so this is a function call. So this is a function, and initial value v, isn't it? And then I can say list, and I can give it a list, and is some list, and this has to be in this bracket. Okay, so let's see if this works. Okay, it says missing one required positional argument x. Okay, let's just fix this. So is my function definition correct? Okay, so now let's see what has happened. This is a lambda function, right? So I'm calling this with a lambda function, and this function is being called here. But to this function, I haven't given the parameter, right? So basically the parameter is going to be v, right? So now that's okay. So now let's debug this. So now you see that this time we are writing it like a higher order function. Okay, so higher order function is update. It receives the final value, the function pointer, and the current value. So what are we doing here? We are saying if v is equal to n, that means that the final value has reached the initial value has reached the final value. Then we are going to return an empty list. If then we call the function with v, and this is a filter function. It is going to test. It's going to either give you true or false, right? So it's going to give you true or false, and we will see this again if you don't understand this. And then what we are returning a list v, and we are calling the function recursively again here, update function. Else we are calling the function recursively. So basically, if the filter is condition divisibility by 3 or divisibility by 5 is satisfied here, so it returns a true, and the list is appended, right? Else the intermediate state v is updated by 1. So that's what is happening here. So this call here is a recursive call over here, right, for the update function. And so this is as simple as that. Now if somebody is confused about what is this going to do, so let's do this. We have a lambda function, right? So we can say func is equal to lambda x such that x is divisible by 3, or x is divisible by 5, or x is divisible by 5. Okay, so this function basically is going to return true or false only. So if I pass to this 5 and try to print this, one, right? And let's do this. Okay, so it returns a true here, right? So what it means is that, yeah, 5 is divisible by 5, right? So let's try this again. Let's say if this was a 2 and run this. So it's neither divisible by 3 nor divisible by 5, so it is false, right? Or I can give here, let's say 3, or let's say 6. 6 is divisible by 3, So the answer is true. So basically we have defined a function which is a filter function using this lambda, right? And what I'm checking here condition is that filter function is doing this. Now, is there more compact way of doing this? Yes, we can use filter function, right? So we can say uh, list is equal to I have to pass a filter function, right? So list is equal to, okay, so is equal to filter. List is equal to filter, and here there is going to be a function. Uh, okay. Okay, so I'm going to make use of a filter function. So I'm going to get a list 1, and that list 1 is going to be a list. So because uh, 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 filter function is going to be a generator, so I have to generate a list out of it. So I have to tell it like this, and then I will call this filter, and this filter function is going to receive a this filter function is going to receive another filter function which is lambda, and x such that x is divisible by 3, or x is divisible by 3, or x is divisible by 5. X is divisible by 5, right? And then the iterable, which is going to be another generator, range of 10, right? Okay, yeah, the number of brackets, okay, yeah. So this is going to do that, and then I'm going to say print f sum of the list 1 is sum list 1. So I'm making use of a higher order filter function here to do the same stuff. So let's see that. Okay, so now you can see I am getting the same list, but this time I have a filter function which is inbuilt. I'm using it. In the earlier case, I was making my own higher order function here to get the list back. So it was, this update function was nothing but a generator, right? Of course it didn't use a yield, so it was not returning, it's not a generator, it is returning a list. So that's why I'm not using yield here, but we can write this with a generator also if I want, right? So now here, that's one way of doing this, and yet another way of doing this would be using comprehensions, right? So how would I use a comprehension here? List 2 is equal to comprehension of a list value for value in range uh, value in range 10 if value is divisible by 3 or value is divisible by 5, correct? So this would be doing that, generating a list, and then I can just do the same printf statement. Control C, Control V. Instead I can give list 2 and sum of list 2. So let's say for value in range this, if value is divisible by 3 and value is divisible by 5. So I'm using a comprehension here. So you see this also works. So now there are different ways of doing this we have seen. One is we are doing the imperative way. So this is the imperative way, right? This is all imperative, right? Now these are having different performance values, right? So there may be one which is more efficient, but then here I'm using a higher order function and functional programming, right? And I'm able to get a list back using this higher order function and then sum it up. And yet another way is doing the higher order function filter, right? And then I can do it, or I can use comprehension, right? So here I'm using comprehension to do this. So in programming paradigm, I have shown you a procedural way of doing it, which is the imperative way, or a functional way of doing it. And there are different functional benefits, right? Now, let's do some more stuff. Okay, sometimes we can change the order without changing the operation. So let's say import, no, from time it, import time it as time func. Okay, so let's see. Okay, uh, print f, okay, in a formatted string. Sorry about this. Okay, time, so I'm timing it. Time taken by the operation. Okay, and this operation can be 2 plus, let's say, 3 plus, let's say, so instead of square brackets, this one, 2 plus 3 plus 4 plus 5 plus 6. Okay, and then 6 closing bracket, 5 closing bracket, 4 closing bracket, 3 closing bracket. Okay, so that's that. Let's see if this is working. Here I want to say time func. So I just created time func, right? And here, okay, print f. So I'm so used to, C. Okay, what did happen? STMT is neither string nor callable. Okay, let me just fix this. Okay, so what I was saying was the following. So if I was to take a module called time it, basically it gives me how much time it took to solve an expression. So I'm importing that as time func, and what I'm doing here is time func, I'm calling the expression as a string. So what I'm doing is I'm adding 2 plus 3 plus 4 plus 5 plus 6, and the precedence order goes this way, that the innermost bracket is evaluated as 6, then 6 is added with 5, that is 11, then the next operation is 11 plus 4 is going to be 15, then if you add 3 to that, that's going to be 18, and then you add 2 to that, that's going to be 20. So here the precedence is going from right to left. In the next step expression is the same expression, but the precision is going from left to right. So what am I doing? I'm doing 2 plus 3 is 5, 5 plus 4 is 9, 9 plus 5 is 14, 14 plus 6 is 20. So the result in both the cases are same. The expression is also the same, but let's see how much time is taken by the first operation and the second operation, right? So if I perform this, so it took me the first one. So let's run this 2-3 times. Okay, so one of the precedence is taking more time than the other one. So this is in millisecond. Okay, so you have to do it a number of times actually, and if it is a bigger expression, then you will know, right? So the natural way of precedence, okay, usually there are other programs running, that's why it is going to do that. But you can see, if I do this 20 times, let's say, then I will come to know which one is more efficient. Okay, so there is a minute difference because the list is small. Right. But you would see that the left to right precedence is going to take less time in most of the cases, right? So if you run this again, right? So you see, most of the time it is the left to right precedence which is taking less time. So I'm doing this again and again. Okay, only few times it is the right to left which is more precise, but then it depends on the machine. But mostly left to right precedence is going to give you. So one of the precedences is going to give you less time. Okay, so that's all the point I was trying to make here. Okay, so when you do recursions, these become important when the recursions are large. Okay, so this is some insight into the imperative programming and the functional programming.